Hello, folks. Welcome, welcome, welcome. I'm Ioana. I'm together here with Chris. We'll say hello in a second. And we're very excited about joining you to our new podcast episode where we unpack what it really means to build trustworthy AI, why this matters, how it shapes the products that we deliver, and the practical ways we can innovate. Chris, hello.
What's up? Hey everyone. So I'm Chris. I'm tired. I've been traveling for I don't know, like I think it's probably around like 27 hours at this point. So I've done like a cross Asia tour, so Hong Kong, Manila, and Seoul, and now I'm in London, and I just literally got out of a cab. But I'm excited because we have a very, very, very special person on this podcast today. Very special. I did some LinkedIn stalking. Sorry, a classic enthusiast. So yeah, yeah, I think we're gonna get stuck in. But Ioana, thank you for putting this together once again, as always. And normally, Ioana is the organized one. I am not. I just rock up and yell. So yeah, hopefully she doesn't edit me out completely on this one. We'll see. Anyway, shall we intro Giorgio?
Giorgio, hello, hello, hello. Thank you for saying yes to having a chat with me and Chris. For those who might not know you, though they're missing out, can you tell us a little bit about you and the work that you do?
Hello, everyone. Thank you for having me here. My name is Giorgio. I am a researcher here at Microsoft. In particular, my research is on AI safety and security. I work with the Microsoft AI Red Team. I joined in 2024. Yeah, I'm coming to the 2 years mark now. And yeah, I come from a little bit of a kind of like academic background, where my research was again in adversarial machine learning, so not far from what I do right now. And yeah, I really enjoy breaking machine learning systems. That's what I do, and that's I'm happy to do it for Microsoft.
Breaking machine learning systems.
I'm laughing right now because the way I explain right teaming to people is our job is to break things before other people break the same things. So when you said that, I was nodding along. But irrespective of my very dodgy definition here of red teaming, for those who are not familiar with red teaming and specifically I red teaming, can you share a little bit just an intro of like what is this thing and why does it matter, especially now that generative AI is here to stay?
Yeah, for sure. So what the AI Red Team does is it performs a series of security and safety and responsible AI tests on models and on, in general, systems powered by AI at Microsoft, so that we find security, safety, and responsible AI issues before these systems are available to the general public. So we can fix them and we can make sure that users interacting with our systems are protected and they're having the best experience.
And that's crucial, right? Because we've seen so many examples of what happens when the models are not properly tested, where risks are not identified in time. And Chris and I have this running list of a GitHub repo that we call when AI doesn't AI, and basically just talks of all the very public examples of things that don't work well. Chris, you're doing a lot of red teaming right now. I know with different clients and partners. What trends are you seeing, or how are you seeing the maturity of different organizations who are deploying AI tools, AI agents, whatever it is, when it
Yeah.
comes to red teaming? Has it increased? Are people more aware?
Yeah, it's it's a good question. I feel like some of the stuff that's come up recently is okay. The best way I'm going to frame it to you is it's a bit like antivirus, right? So I don't know if all of you all remember this, but like back in the day, you would install an antivirus system on your computer, and then something weird would happen in your file construct, or like something would pop up saying, deposit $25,000 into my account, and then what would happen is that there'd be like an update from the antivirus onto your system, and then hey ho, the thing was gone, right? And I feel like people are just getting imaginative and trying to kind of bypass the layers just to see what they'll do, which is fair because we're humans. We do things because we're curious.
I remember, I think it was even 2 years ago. Like, and actually, let me take a step back. Like in the old days, where we were talking about SAO poisoning, right, and that became a big thing, where we were talking about the influences of that. Now, fast forward, I was reading, I think it was a 2 years ago about the first things about data poisoning when it comes to AI models. I know that you folks have done a ton of research there. Can you share a little bit more about your research and the things that you found out?
Sure. Yeah. So we can take this from two perspectives, like how poisoning is done and how it evolved over time, which I think is a pretty interesting topic, and what we are currently trying to do, what we're currently working on, to both like develop new poisoning methodologies in order to study them, right, and develop mitigations in order to defend our systems.
Oh, let's
Oh,
discuss
okay.
all.
Perfect. So yeah, okay. So definitely poisoning in general as a form of tampering with data is not a new thing. So when I refer to poisoning, let me give some sort of definition. It's going to be a vague definition because it's a broad research area. So I'm going to have to be vague. But what I mean when I talk about poisoning is it is kind of like broad collection of techniques, adversarial techniques, that the adversary can use to tamper with what the system learns or references, so that any future behavior of the system can be influenced by this attack. And again, pretty vague, as you can imagine, because what it learns from and what it interacts with and what the references can be anything from like training data to fine-tuning data to the reinforcement learning environment that the model interacts with to the RAG dataset, retrieval augmented generation dataset, that the agent has access to. So this is very big. But anything that the adversary can tamper with and can make persistent is going to be a point of leverage that the adversary can use to influence future behavior. So like poisoning again existed, has been studied for many years. If we go back in time, early mid 2000, we had attacks that were targeted at worm signature generators,
Mhm.
to internet worms. Right? That they were these systems designed to find internet worms, and people started designing attacks to tamper with the data that these signature generators used. With the evolution of the AI and machine learning field in general, we saw more and more research targeted at interfering with what are modern machine learning models. So things like support vector machines back in the early 2010s. Going forward, there were a bunch of attacks aimed at reducing model performance. So
Mhm.
any type of model reducing its ability to do its job correctly. But then over time, again, people started being more interested in targeted attacks, right? Because you don't really want the model to be useless. That wouldn't really be useful to anyone. You want to obtain a foothold in the system. And so people started designing attacks to do targeted poisoning, where just a few test points would be impacted, or subpopulation poisoning, where some part of the test data population would be impacted. And finally, in 2017, Gu and others from NYU, they published this paper called Bad Nets, which kind of introduced the concept of model backdoors in modern machine learning models, in particular for image classifiers at the time. And I think that is kind of like a big turning point, because model backdoors are these idea of an adversary being able to introduce somewhat of a conditional policy, like an if statement that is learned by the model. And these, I think, had very significant impact on the field, because a backdoored model is a model that acts normally pretty much all the time and only acts adversarially or misbehaves in response to very, very specific inputs.
Mhm.
And this makes securing these kind of systems really hard because you don't know that something is wrong, right? What Chris was telling us earlier. There are things you don't know that you don't know about. And this type of attacks is designed to be an unknown from the point of view of the defender. And so that's kind of like how it evolved. And now, obviously, with language models and agents, like this concept has been ported to the large language model world. There is a famous paper from Anthropic called Sleeper Agents, showed how you can inject backdoors into large language models. And once you can do that, you can think of backdoors designed for specific tool usage. And so you have this situation right now where these models can be poisoned, and we know it is a possibility. There is even recent research that showed that you don't even need that much poison training data in order to introduce a vector in a model. And so we know it's possible. It's not super straightforward to do, but it's possible. And we are embedding these models into complex agentic setups. And so these vectors, these conditional behaviors can have like actual real world repercussions when they're triggered.
Chris has a question. I can see it.
I'm so fascinated by this. Like, there are so many things in my brain right now. It's like, Giorgio, there's about a million things I want to ask you, but like, so I think something that interests me, and I'd love your opinion on this, because Ioana, you and I have spoken about this, is that like when it was just RAG, retrieval augmented generation, you could poison a model and kind of mess with it, but all that was happening was people were giving the wrong info, right? But now there's like another layer that I'm struggling with, and that's when you look at these utility-based agents that are action-driven. So like you can have an MCP server that is then poisoned into doing actions incorrectly or actually doing the wrong thing, right? And that's physical. That's like, hey, we're going to go and mess with this other data. And then the next thing that goes into my brain is like, okay, now we're talking multi-agentic systems. So you have agent A, agent B, and agent C. And agent A is poisoned. What happens to agent B and C? And then like the mitigations and all of that. So, man, I'd love to hear your opinion on any of that. Like, it doesn't even matter if it's high level, low level, an opinion, not an opinion, anything that you can use to pry my brain, because I have all the questions.
Yeah, that's a huge research space.
I'm so
It's a
sorry,
really
man.
good question. So the way I try to look at this is we should try to stack our defenses. So I think we should defend at different layers, and we should concatenate these defenses together. So first you have the model layer, right? You want to try to figure out if the model has been poisoned, right? If it has been backdoored, either during training or by direct tampering with the model weights. That's also a possibility. Once you have this layer, right? And then you have the layer of the tooling, and so you want to make sure that the tooling respects some guardrails, regardless of what the model says, right? Like you get a poison models that does something really, really bad, but you still want your tooling to give you some guardrails in case that happens. And then you have the interaction step with different models. And again, you want to make sure that whatever comes out of any of them is mitigated and processed in a way that it doesn't create cascade events where everything starts exploding and you lose all your security guarantees across the system. And these are like three different steps for which we need three different types of, or probably more, but at least three different types of defenses, and we need to stack them together. And we can't, I think, at least in my point of view, we can't really rely on like any one single mitigation. We need to have these, the term defense in depth is kind of maybe overused a bit in the industry, but the idea is it's a solid one, right? We need defense in depth. We need multiple layers.
I have an even more basic analogy, which is Swiss cheese, right? There's going to be holes. And how do you make sure you don't overlap those holes? Because then you have a bigger issue as opposed to trying to patch them up.
Exactly. And I think this leads us nicely to the second part of the answer to Ioana's question, which is what are we trying to do right now? And at least from my side, right, my personal interest, I want to start from the beginning, so from the model level. And we're trying with my team to figure out mitigations that can be applied to the model at scale. So as you can imagine, this is a very, very active research area. A lot of people have developed defenses against model poisoning, model vectors, also for LLMs specifically. But what we noticed is that they are really difficult to scale up and implement over, like, for instance, a model hub, right? A repository of many models that users can go and interact with. And this is a major limitation in my mind, right? We need to find an approach that we can, just plug into a model hub, scale to the size of however thousands of models are hosted, and make sure to get some. We're probably not getting guarantees out of it, but at least we're getting one more layer of assurance, right? Like one more layer of defense from these.
Confidence score. Something that at least gives us some sort of perspective or direction, or like, hey, this is your risk profile. It might not be 100%, but you have an indication of something.
Exactly. And so this is kind of the work we're doing right now. We've recently published a paper on this. It's called "The Trigger in the Haystack."
Love the name.
Yeah, I did not came up with that. Blake from my team came up with that. So it's a good name.
You mentioned the paper that you and your team published, and Chris, you're gonna love this. I've experienced this by complete chance, and the paper is, I think, something that everybody who works in this space needs to read, or somebody who's building AI needs to read. Can you tell us a little bit about the paper and kind of what are the things that you folks publicly shared? Because I know there's always there's a process to being able to share and publish.
Yeah, definitely. So our objective here was exactly what I was mentioning before, which is trying to design a backdoor defense system. In particular, we're interested in identification, so trying to figure out if a model has been backdoored. That does not rely on too much additional information or too many additional capabilities from the point of view of the defender, so that we can actually scale it and run it automatically on like a large collection of existing models. And so the idea was like, the core concept was, can we really look hard at a set of model weights and try to see if there is anything wrong with that, right? And the way we do this is by looking at a set of backdoor models and trying to infer if there is any consistent pattern that we can observe across these backdoor models. And we saw there are a few things. We saw that there are some internal dynamics of the model flow that are modified by the presence of a vector. So that when the trigger, right, the pattern that activates a vector is present in the input, some effects are observable in the model. There are things like there is a collapse in the output distribution, which means the model becomes very sure of a specific output when the trigger is pressed, which is not something the model would do normally. We saw particular attention patterns when the trigger is present in the input that are not visible when the model is operating on normal text. And we also, may sound kind of obvious, but the model should, in the presence of a trigger, should respond with something, right, that is significantly different from the thing it should respond with when there is. right? The model should alter its behavior significantly when there is trigger. Again, it sounds a bit obvious if you say it like that, but it's something we can measure in the dynamics of the model, and this is a signal we can use to try to identify a trigger.
Yeah, yeah. I mean, it logically sure, but I mean, when you say it out loud, I'm like, my brain's just chewing through the number of things and triggers and variances. It's like, okay, I mean, I don't want to interrupt, but I've just got to ask you this question. So back in the day when I used like, this is 2002, man. I was writing solutions in like Ball and Delphi 5. And we always spoke about this thing called the timetable paradox. And the timetable paradox, think about it like you have a university, and in the university you have an unknown number of students, you have an unknown number of subjects, and an unknown number of times with an unknown number of classrooms, and the variations of matching all of those things are just unknown because like you have 52 students taking algebra, another 50 students taking applied mathematics, another 50 students taking geochemistry, and then you have to map the rooms and the teachers and facility. It's like crazy. The number of variables that have to match up to make it real are insane, right? And I remember people talking about this and never ever being able to build it until tools like AI, right? But I feel like we're in this paradox once again where the number of things we have to consider here are just limitless. And in my brain, like I can't, like I want to think I understand it all the time, and then when I hear you speak, I'm like, man, there's just so many things I haven't thought of. And like, how do you guys cope with that on a day to day? Like, how do you check stuff off, saying, yeah, we've done this,
That's a good question, and to some extent, we can't know everything, right? So we can't
Yeah,
test for everything, and this is true. Like I think for like most cases, most of our work, not just in the
yeah,
finding backdoors space, but also in general. There are some approaches that, especially in poisoning defense world, in research, that gives you guarantees, like mathematical guarantees of some properties. Unfortunately, these types of approaches are usually either computationally expensive or they require some particular setup or information, or maybe they degrade performance of the model. And these are all things that are trade-offs and are acceptable in some cases and are possible in some cases. But if you think of like, you just want to test all the models in a big hub of 20,000 models, right? You're probably not going to be able to do that, right? You're not going to be able to have those guarantees. And so this goes back to the defense in depth idea, because we can't really have these certainties, or it's really, really hard to have those certainties. And so what we can do is to try to design defenses that are easy to run and easy to stack one after the other. And we're going to miss stuff for sure, right? There is stuff we're not going to be able to catch. But the more we improve on them, the more we iterate on them, and the more we stack them, the better we're going to get over time, I think.
yeah. And that goes back to my antivirus analogy. It's like the more we train it, the more we change, the more we upgrade, the better we get, right? And I think like we're in this weird phase of learning, in my opinion, right? Like I think there's so many unknowns and so many variables, and I think we're still picking up all this knowledge. And thank God for people like you, because genuinely, man, I just like it's huge. It's just massive. And yeah, that's why I always make the antivirus analogy. It's because we're in a position where we're just getting this right. So yeah, I'm honestly, man, I think you have one of the coolest jobs in the world.
And the hardest.
Yeah, and
Right.
yeah. I'm sorry, I should have caveated that, and the most difficult. Yeah,
I don't think it's the most difficult, but I do think it's the coolest, and that's why I'm doing it.
yeah.
You mentioned a little bit, obviously, that you folks are looking at the data poisoning side of things. You're looking at the model side of things. And this might be too early to talk about, but I'm curious, are there things when everybody's moving into agents in terms of building agents, monitoring agents, hopefully they're monitoring agents, and thinking of how their kind of agents are running amok their enterprise. When it comes to agents and data poisoning, are there things that you can share that your team is considering or you're seeing in the industry in terms of like different paths of research that people are taking, especially as we think of enterprise data? And here's where I'm coming from. There was this article 2 years ago that was talking about data poisoning, especially in the enterprise space, where like, what do you do when you have a bad actor? Doesn't even have to be internal, but like there is a data poisoning attack, and then you have AI systems that are not properly monitored or mitigated or whatever word of the day we want to use, and that causes you to have some sort of enterprise harm. So that's where I'm going with that question. Like, as we're thinking of data poisoning, enterprise scenario, agents, are there things we need to know today?
Yeah. Quite
Easy
a
question, I know.
That's
Yeah.
so difficult.
Low
Uh,
ball question.
yeah, the short answer is yes, there are so many things. But to give you a little bit more context, so there is definitely the poisoning angle, the model poisoning angle, which we talked about earlier, which I think it's very important right now because people tend to reuse models and share models and fine-tune models incrementally. And sometimes it's possible to trace back the origin, right? And
Oh, wow.
trace which group or institution or individual has fine-tuned the model and how. But sometimes this data is lost, right? This tracking information is lost. And so you don't know like the origin of the model you're using. So that's one thing. And then there are a lot of considerations about the agentic setup. And I cannot say I'm an expert in all of them. I don't know about all of them. What I've been thinking of recently, particularly, is the concept of memory in agentic setups. So we know that these agents have to respond to different tasks, and they have to do it in a way that resembles the user as much as possible, because that's where the value is, right? We really want our agent to be as good as ourselves in performing the tasks. And so these agents have to learn dynamically during deployment how to perform these tasks. And so we started adding memory to these agents. And memory is great because it lets us personalize them. It lets the agent perform better over time because it can see how it performed the task the time before and then say, okay, is there anything else I can do now? Can I do it better? Can I iterate on that? Which is great from the point of view of performance, but it also introduces a whole new set of security issues because this memory is persistent, right, over iterations. And so it kind of shifts the idea of something like a prompt injection from once in an interaction kind of thing, right, like single point in time, to a persistent foothold, a persistent vulnerability in the system that can be reused, re-exploited, and re-referenced by the adversary later on.
Going back to what Chris was saying, of course, when you say it makes sense, but the fact that you just said it, and I was like, this makes a lot of sense, and I've not thought of that. If I'm an emoji right now, is that head, the head exploding emoji of like, oh goodness me, I haven't even thought of the prompt injection attack and how that just transforms into a persistent attack because of memory.
Yeah,
Fascinating.
but the problem, that the thing that scares me about that, right? Because I kind of had a weird liberation moment on that, where it is persistent, but the thing is, like, what we see, when people do like a random jailbreak in an AI tool, they're like, tell me X, Y, and Z, like a basic crescendo. It's like you can lead it down a very similar line, right? But when you infect that memory and it happens in split seconds all the time, consistently like that, I mean, what is the end result? Like, what is the byproducts of that? And what does relentless attack look like? And that's the thing. I want to know, because when we test these things out and when we red team, as an example, Giorgio, like we're doing very, very basic manual jailbreaks as a kind of standard example, as a proof. But when this is relentless, what happens to memory? And what happens when you overfill memory? What does that look like? Like, how does memory leakage work? What is, like when you fill up a Coke bottle with, more than 2 liters of Coke and you shake it, or when you fill it up just a little bit and you shake it, what happens? Like, what is the deal? And this is the thing. I mean, you want to, just exactly like your brain is doing the exploding thing, so is mine, because I think about what happens in the real world. And when we see these demos and we see people explaining this stuff, I'm like, oh, that's not so bad. I can grab a bit of info and fire an MCP server. But then relentless attacks, that's crazy. So what about scale, Giorgio? Like, do you guys talk about that internally?
That's a big thing. So scale is definitely important for all the different aspects you were correctly listing, Chris. You have things like how many times a specific behavior can be triggered by the adversary, which it could lead to like overwhelming if you have a security classifier downstream, right, that tries to intercept some malicious behavior. But if the malicious behavior is repeated many times, maybe in different contexts, in different scenarios, maybe one of these times is enough, right? And it flows through, and the downstream classifier can catch it. You have things like reliability issues that could come up with memory pressure, right? Memory pressure is a term that is used to talk about how filled up the memory is, right? So if you fill up the memory a lot with a lot of spurious information, does the agent perform as well as it would perform with a clean memory? And then there is targeted memory poisoning, right? If the adversary places some spurious facts, data, malicious information, even just preferences, right? There is this work. It was from the Microsoft Defender security research team. This is a blog post that came out in February, I think. And they showed that there are already some people in the world that are groups that are trying to manipulate AI memory for profit, right? They try to introduce spurious preferences so that the agent suggests some specific brand or some specific product to the user when the user asks for something.
I think I've seen this one, and I think we were discussing this one where actually the ranking weight, whatever we want to say it just gets influenced by that, and you get certain recommendations persistently and come as a sort of objective ones, as opposed to either flagging them as that, hey, this is advertising, or this particular recommendation is based on ABCD. Super interesting if you think of it. How do you take something that you say, hey, I use researcher all the time, right? So I might be doing some sort of research and say, qualify this particular 5 products for me and do a comparative analysis, real use case I use it for. And then suddenly you have something like data poisoning that influences the results you get and the way that certain things, and you get X as like, this is the preferred only because you have data poisoning in there. It is fascinating.
Yeah, but this is where like this whole thing comes into the guise of optimization versus poisoning. It's like, hey, we optimized the thing. I'm like, no, homie, you poisoned the thing. And like, I remember with SEO, it's like, oh, we're going to optimize our website by adding all these specific little search tags and things. And I'm like, where's the line? Because if you found a way to optimize legally, then you're optimizing. But if you're prompt injecting and poisoning, then you're poisoning. It's like this is where this weird like trustworthy AI shared responsibility model comes in, because
one person's poisoning is another person's optimization.
yeah,
So
guys, I just optimized your model. Sure. I didn't mean to optimize your file system the way I did.
Fascinating. Yes. And I remember the article. I didn't realize it was from the Defender team, but fascinating in terms of, hey, these are the type of things that people might try to manipulate. And items that, I wouldn't even think about, but I guess my brain is not into that type of breaking the model or optimizing.
And we're pretty early on, right? Like memory and agentic setups, this is relatively recent. The world of AI is going so fast, and that saying something like that, it kind of sounds weird, but if you think in a grand scale of things, this is relatively recent, and so like seeing that people already in the world are just probing at these systems in this aggressive for-profit kind of way, at least to me, it gives me this signal that we really need to be careful about this, because it's kind of already happening, right?
Agreed. And it's interesting because I was having this tangential conversation, and I know I'm going more into the legislation side of things as opposed to technical research of it. But even the context of with memory, something that, as a particular example, what are the legal implications? And they're not unified, right? If we look at memory and the EU, we all know and live in the EU in the sense of like at least understanding the landscape because it affects us despite where we are in the world, and based in the world. But if you think of memory, there's things like GDPR, there's things like UI Act, there's things like the European Accessibility Act. There's so many different things that kind of touch upon those subjects. And then you think of like something like data poisoning, and you're trying to map out what is the legislation landscape regarding optimization or not. And with certain things, it's also a matter of how do we think of that landscape, not just from a security perspective, from a legislation perspective, and how that evolves. I know that we can talk with you about this the whole day, but I'm also mindful of your time. I always have a question for our guests, and that is, if you were to give our audience homework, what would that homework be? So I have the same question for you. What homework are you giving us all?
Oof, that's a difficult one.
And
I
don't say break the systems because we will.
I mean, if you want to, as long as you do it in a responsible way, I would still encourage that. But I would say if you are developing an AI system, an AI agentic setup with memory, I would say take time to really carefully map out, like on paper or on whatever substitute for paper you're more happy to use, but really map out all the ingress and egress channels from memory, right? Who writes on memory, where, when, and track them, right? If you can, so that if you see that your system performs web searches and then writes on memory a lot, is that something you expect, or is this like an XPIA, a persistent XPIA waiting to happen? XPIA, sorry, is cross prompt injection attack. And so really be mindful and threat model memory explicitly. I would say that is my suggestion.
I love that. And that's something that Chris and I can take to on board as well as we're building different systems and we're looking at the, let's say, journey end to end where things are meant to be connecting. That is super practical. So thank you, because I know that oftentimes people are like, that's great, but what can I do? And this is something that very tangentially everybody can do. And I'll add to that homework is go to the resources that Giorgio mentioned and we'll link
Yes.
them out and go and read them and get familiar with the topic. Chris, anything to add before we say goodbye for today's episode?
I'm gonna add in a bit of a human element to this whole thing because Giorgio, I love how you've broken it down, man. I'm so fascinated. I've watched the time of this podcast tick by very quickly, and I'm really sad because like I'd love to pick your brain on stuff, man. You are totally fascinating in what you're doing, and I'd love to learn.
You're gonna make me blush.
Man, it's true. I really am. I mean, Ioana and I've been talking about this from the very get-go when all of this started, and her and I have both been truly keen on like getting involved and understanding more. The one thing, and I guess it's a question to you, maybe, and a statement from me, is that like when you are testing these models, like when we have tested these models, we've had to do some pretty awful research into some subject matter areas, especially with responsible AI and like inclusivity and that. I mean, I've tested models that have gone up to the police forces and things, and you have to ask them some appalling questions. It's not always as simple as automatically red teaming. You have to go in and actually do it manually and ask some horrible questions. I think it's a twofold thing. So I'm going to tell you, I'm going to tell you what I do, and I'm going to ask you what you do to kind of, bring this to an end. Ioana, I'd love your opinion on this as well. But
Sure.
when we red team this stuff, okay, I found myself becoming highly manipulative in my general day to day. I found myself getting very sort of moody because I'm having to put in some very negative things into these models and ask it like awful questions. And yeah, I've found like sometimes it can put me in a really bad mood. It can change my mood. It affects my day. So what I do is to stop doing that, I have a thing called a brain shower. So to quote my friend Christina Libby, what I do is I'll go and paint a picture, play some music. I've got a drum kit sitting over there. But like I found myself having to get rid of what's in my head when I do these types of manual tests. Okay, so that's me. But I'd love to know, just to kind of wrap it up, what you guys both do and any advice you have for people.
I can go first, because this is very timely as we're going through an exercise where we're doing all sorts of annotations on things that are less than savory. I know this will sound a little bit cynical, but in many ways, I really desensitized. Like I am now at the stage where I've been doing a lot of testing, and it takes a lot to phase me, in the sense of the output and certain things I've become desensitized to. Now, that being said, there's still going to be things that get to me, especially as I'm looking at, human representation in systems and things that have to do with fairness and equality. So I'm going to steal your word, Chris, but I have ways to kind of break those up. And when I feel like, hey, you know what, this is becoming a bit heavy, I I simply do think that bring me joy. Be it that I put on some music that I really enjoy. I don't know how to play, but I can listen to music. So, or be it that I go in the garden and just look at birds and the trees, and it's just a nature cleanse. So, and also there are, by the way, for people who write team, you really should think of what are your mental health resources as well, and what are things that you can tap into in terms of, hey, I need support, I need to discuss this, this is getting to me, and getting people to help with those mechanisms and coping items. So we also have internally, for example, a whole support system, including mental health resources to support with that. And one thing about red teaming, especially as you're going towards the more harmful things, as a company, if you're doing that, make sure that your employees have those resources. It's not a matter that everybody should write team. They should not. And if you feel that those things are getting to you, stop. That's my advice. But Giorgio, how do you see it, and how do you see it in your world?
I think you definitely covered it well, Jan. I think so. I personally am lucky on this side because I work mostly on the research and methodological aspects. And so I'm actually a bit shielded from some of the worst part of it. But there are many operators in the AI red team that have to deal with that kind of stuff every day, all day, and it's really tough. And there are, as you said, internal mental health resources that we can all use, and I think it's important to use them. And just in general, the way I try is I try to detach a little bit
Mhm.
my like work self from my outside self. And I don't know if it's really successful as an attempt, but I think that's what I try to do.
It's a
It's a
way to do
healthy
it.
habit.
It is cool. I mean, look, I agree. But I will tell you that this world that we're in now is totally fascinating, and I feel like this new realm of understanding how these tools work, it's completely opened my mind, totally. And this conversation has again blown my brain. So just from my side, Giorgio, thank you, man. It's been super good to have you on this call, and thank you for taking the time. I know you're a busy guy, and yeah, man, I've learned a lot. I'm gonna be bothering you again. I hope you don't mind, but I really do like what you do. It's super cool.
I'm gonna echo that. Thank you. I've learned so much from you, from internal calls and the things, and there's research that your team publishes. So thank you. I hope everybody goes and checks it,
Yeah.
because this is important. And even if you're not a AI developer, but you're a user, go and check these resources because they're critical. And as consumers and users, we should have a very informed opinion about the tools that we use, how they're being measured, how they're being mitigated. It makes a world of difference. So thank you. And please share that thank you with your team as well, because I know you're part of a fantastic team. And folks, with this, Thank you for joining us. That's a wrap on today's voyage aboard Human in the Loop. We'll be back next time with more conversations about AI you can trust. Thank you.
Thank you all for having me.
Thank you.